Now, scientists have a wild theory. What if our entire universe is actually inside a black hole? This is called the black hole cosmology. Some scientists have the idea that our observable universe and everything we see around us might be tucked inside a black hole, which exists inside another parent universe or even multiverse. And then this multiverse could be part of a bigger one, and so on, kind of like a stacking doll. Sounds like pure science fiction, but this is based on some curious facts. When scientists create the timeline of our world, they say that everything started from a singularity. If you kept squeezing a giant ball smaller and smaller, at some point it would get super dense before it crushed. Well, it's hard to imagine, but in space, it's possible to squeeze a crazy amount of mass into a teeny tiny point. This point is called a singularity. The matter gets crushed into an infinitely small space, less than an atom, and it holds all the same mass of everything, while taking basically no volume. Inside this singularity point, things get so intense that the normal rules of physics just stop working. Everything we know – time, space, matter – breaks down and can't be applied anymore. Basically, what happens from now on is beyond our understanding. So, scientists say that this was the starting point of our world. When the Big Bang happened, it's like this tiny dot with everything inside it expanded to everywhere. This started forming the universe as we know it. And here's the thing. Scientists assume that singularity also exists deep within black holes. General relativity says that a black hole is born when something really big, like a huge star, collapses under its own weight. Gravity gets stronger the bigger the mass is. With a mass of a huge star, tens of times bigger than our Sun, this tiny point would have an unbelievable gravity. It's why it starts sucking in all the stuff around it and curves the fabric of space-time so much it looks like a hole in space. And this would be the center of a black hole. It's a dot where all these things fall into and get crushed into an infinitely dense point. So, could our universe itself be just a little singularity dot inside a huge black hole inside of another universe? Well, that would be wild. So, it's not that easy to compress something so much that it literally warps space-time. You'd need to squeeze it like crazy. If you wanted to make a small black hole, like a human size, you'd need to shrink them down to the size of an atomic nucleus. If you want a black hole the size of a chickpea, you'd have to compress our entire planet to that. But our universe is 99% empty space. There are trillions of miles of just nothingness between the stars. If you were to pack all the matter in the universe together, the result would be surprisingly small. Everything around us, including galaxies, stars, planets, and dust, would only fill about 1 billion cubic light-years. It would be a cube about 1,000 light-years on each side. For comparison, our Milky Way alone is 100,000 light-years in size. That's how sparse the universe is. But at this density, it would also be very, very massive. The resulting mass would likely collapse into a black hole. And here's the wildest part. The resulting black hole would be roughly the same size as the universe itself. It would also have the same mass and energy, as well as the same average density. The size, or radius, of the black hole grows together with its mass. The more stuff it eats, the bigger it is. But the density works the other way around. The black hole gets less dense as it grows. For a size that big of our entire world, it would be pretty sparse as well. And it's not the only coincidence. We have this thing called the Hubble radius, also known as the cosmological event horizon. If we imagine our observable universe as a giant bubble, then think of its edge like the farthest part of the universe we can see. When you stand in a field and look around, trying to see as far as you can, your eyes will draw a circle. This is like that. There might be more beyond that point, but we'll never know. Beyond this horizon, the light from distant parts of the universe will never reach us. That's because light travels at a certain speed, and the space between us and those regions is expanding too quickly. It's like running towards something while super strong winds try to blow you away. Until we stay on Earth, we're cut off from those far-off corners forever. The black holes have something eerily similar called an event horizon, or the Schwarzschild radius. This is the point of no return. This is the imaginary line that's often depicted as a light contour around the black holes. Anything crossing an event horizon, falling inside, is lost forever. No light, no matter, no information can escape from there. Black holes' gravity is way too strong, so they're perfect space vacuum cleaners. And as we mentioned before, if we create a black hole the size of the universe, they would have the same mass and the same event horizon radius. Now, while some scientists think this could just be random coincidences, others believe it's a clue that our universe might actually be inside a black hole. The theory also suggests that our universe might not be the only one. It could exist in one of many black holes scattered throughout a large multiverse. In this crazy model, each one of them, both in our world and our parent world, could lead to its own universe, with its own set of physical laws and structures. Now that would be some weird chain. There's this theory that says that universes could be born inside of black holes, sort of. It's called the Einstein-Cartan theory. This idea talks about singularity as well, but in a different way. It says that instead of collapsing into an infinitely dense dot, the matter might create a wormhole. This is like a tunnel through space and time. This wormhole, also known as an Einstein-Rosen bridge, could connect two different places of our universe. In that case, one side of the tunnel is the black hole, and on the other side, there would be a whole new universe forming. So it could work like a teleport. As soon as you pass the event horizon, you travel to the new world. But in that case, there should be an exit. Some scientists made it up and called it a white hole. It doesn't literally exist, not as far as we know, but it could be possible somewhere on the other side. It would serve as an exit of a wormhole, an area where matter is always ejected instead of pulled in. So it's like you can't throw anything in there, it would get expelled immediately. That's all purely hypothetical, of course. All this stuff fits well into the concept of the Big Bounce. This idea says that instead of our universe beginning with a singular Big Bang, it bounced from a previous state of collapse. Remember the squeezed ball analogy? Well, maybe there used to be another universe ball that got super compressed to a minimum size before rebounding and expanding again. So instead of a universe born from nothing, we might live in one that's a cosmic recycling of another. There's also another version of this theory, sometimes called shockwave cosmology. The idea says that the Big Bang could have been caused by a boom inside a black hole, and this could create the expanding universe we see today. As the universe expands and the matter density decreases, the black hole would eventually transform into a white hole, the reverse of a black hole, where matter is expelled instead of pulled in. But even though we have all these interesting connections, they're not evidence. There are no experiments or observations that could prove or disprove these wild theories. So they all remain speculation for now. But at least it's fun to speculate. Well, we've been miscalling Uranus all this time. Actually, astronomers say we should be pronouncing it like Uranus, not Uranus. I can't say a different stress changes much, though. However, things could have been different. Initially, Uranus was supposed to have the majestic king-like name of George, because astronomers wanted to name it after King George III. In the end, they changed their minds, and now, well, it's the punchline of every joke. If you take the total cost of launching a mission and divide it by the weight of the cargo, you'll see some pretty mind-blowing figures. According to specialists, back in 2016, it used to cost $10,000 to send just 1 pound of cargo into space. But now, prices have gone through the roof. Cygnus spacecraft's cargo costs over $43,000 per pound, while SpaceX's new carriers come in at around $27,000 per pound. Remember how hard it is to pay $5 for water at airports? Now, a bottle of water in space would cost somewhere between $9,000 and $43,000, and that's only to have it delivered in space. Now, as for water in space, well, it used to be considered a super rare thing. But in reality, there's water ice all over our solar system, so you don't have to buy those overpriced 43K water bottles. It's hanging out there in comets, asteroids, and even in hard-to-see craters on Mercury and the Moon. We're not sure if there's enough water in these places to support colonies of people, though. Mars also has ice at its poles, hiding under the surface dust and frost. Even smaller celestial bodies, like Saturn's moon Enceladus and dwarf planet Ceres, have ice. NASA scientists think there might be a chance of finding life on Jupiter's moon Europa. There might be liquid water beneath its icy shell. Europa, even though it's a lot smaller than Earth, might have an ocean deep enough to hold twice as much water as all the oceans on our planet combined. In 2009, scientists exploring a massive cloud of dust and gas in the center of our galaxy stumbled upon a fascinating surprise. They found ethyl formate within the cloud. This chemical is responsible for the delightful flavor of raspberries and has a rum-like scent. Furthermore, another nearby region is brimming with ethyl alcohol, the same type found in many beverages. In fact, there is enough alcohol in this region to provide every person on Earth with 300,000 pints of beer every day for the next billion years. Now, believe it or not, we do have a black hole on Earth. The thing is, creating an in-lab black hole was a sort of indispensable thing to do. Studying black holes in real space remains a distant dream, so it was only possible to create one to experiment with in a lab. A group of scientists in the Netherlands wanted to explore the mysterious Hawking radiation theory proposed by the iconic Stephen Hawking. Using atoms to mimic an event horizon, they orchestrated electrons, causing a surge in temperature that resembled flat spacetime. As particles moved through quantum fluctuations, a ring of infrared radiation appeared around the lab-grown black hole, mirroring Hawking's idea. So, if you totally understood what I just said, could you please explain it to me? Now, it may sound insane, but you can totally be allergic to the moon. Long story short, it was the final Apollo mission, and they brought back more rock samples than ever before. Plus, they had the first and only pro-scientist on the moon, Jack Schmitt. He was a geologist, and his rock samples helped scientists learn more about the moon's magnetic field and volcanic history. During the expeditions, it became evident that Jack Schmitt was allergic to moon dust. The gritty, sticky powder clung to his suit and his skin, causing irritation in his sinuses, nose, eyes, and throat for a couple of hours after he took his helmet off. Meanwhile, neutron stars are extremely dense, being basically just a bunch of neutrons squished into a super small space. If you had just a teaspoonful of this stuff, it would weigh more than the entire human population combined. And to match the density of a neutron star, we'd all have to squeeze into the space the size of a sugar cube. No thanks. When it comes to outer space, we tend to think that Earth and the Moon are pretty close together. But in reality, you can actually squeeze all the other planets of our solar system between Earth and the Moon. The average distance between them is about 240,000 miles. If you added up the diameters of the 7 planets, you'd still have some room to spare, about 5,000 miles. In 2011, scientists made a groundbreaking discovery of a massive reservoir of water in space. This water, equivalent to 140 trillion times all the water in Earth's oceans, could provide each person on our planet with a planet's worth of water 20,000 times over. This reservoir was located near a massive black hole drawing in matter and emitting energy, known as a quasar. The water was formed by energy waves colliding hydrogen and oxygen atoms together, and it was found around 12 billion light-years away. So, when the Curiosity Mars rover snapped its very first sunset picture in 2015, scientists were practically doing backflips from excitement. Turns out, sunsets on the red planet are anything but red. They're actually a stunning shade of blue. According to NASA, the reason behind this phenomenon is that the dust in Mars' atmosphere is like a magical filter that lets blue light shine through while blocking out those warm tones like yellow, orange, and red. Well, Venus is a slow spinner compared to Earth. It takes this planet 243 days to make a full rotation, and it spins in the opposite direction. But even though Venus takes longer to spin around, it zooms around the Sun in just 225 days because it's located so close. So, believe it or not, a year on Venus is actually shorter than its day. So, you might think that the night sky should be full of stars with no dark spaces at all. This idea is known as Olbers' paradox, named after German astronomer Heinrich Wilhelm Olbers. He thought that if the universe was infinite, unchanging, and timeless, then we should see stars everywhere we look. But it turns out that the universe is not infinite, unchanging, or timeless. Edwin Hubble discovered that the universe is actually expanding, and the leftover radiation from the Big Bang tells us that the universe is about 13.8 billion years old. Think of all the birthday candles. Ooh! So, the reason we don't see stars in every direction is because some stars are just too far away, or they haven't been around long enough for their light to travel all the way to us. During the Apollo 16 lunar mission, Ken Mattingly, the command module pilot, had a bit of a scare when he realized his wedding ring was missing. The whole crew frantically searched the spacecraft for it, but no luck. Finally, on day 9, while Mattingly was on a spacewalk, the ring was spotted floating out the hatch door. Charles Duke Jr. tried to grab it but missed. Luckily, it bounced off Mattingly's helmet into Duke's hands. It's cool they found the ring, but there are many other things people left up there. There's even a toothbrush floating around somewhere. Mercury is already the tiniest planet in our solar system, not counting Pluto, of course, and the second densest after Earth. And believe it or not, it's actually shrinking and getting denser. For a long time, scientists thought Earth was the only planet with tectonic activity. But that all changed when the Messenger spacecraft flew by Mercury, giving us a detailed scan of the whole planet. In 2016, Messenger discovered these cool cliff-like formations called fault scarps. Since they're still relatively small, scientists think they're pretty new, suggesting that Mercury is still contracting 4.5 billion years after the solar system began. And around 10 years ago, Australian astronaut Luca Parmitano went through a near-drowning experience during his spacewalk due to a water leak that went unaddressed. Nobody knew how it happened and why Luca ended up having water in his helmet. NASA was investigating the issue for months, but they were unable to determine the exact cause of the water entering Luca's helmet.
Astronomers have discovered the most massive stellar black hole ever spotted in our home Milky Way galaxy. This newly found space monster is 33 times bigger than the Sun and sits 2,000 light-years away from us. Until recently, the largest stellar black hole found residing in our galaxy has been around 20 times as big as our star in terms of mass. As for the average stellar mass black hole, it's usually about 10 times as hefty as the Sun. Scientists from the European Southern Observatory's Gaia mission spotted the giant black hole after a star started to wobble while orbiting in that area. The black hole got the name of Gaia BH3. The proximity of this space object to Earth makes it the second closest black hole to our planet ever discovered. The nearest one is called Gaia BH1. It's hanging out around 1,560 light-years away from us. This uncomfortably close neighbor has a mass of about 9.6 times that of the Sun. It means that it's way smaller than the newly found black hole. Gaia BH3 is located in the Agila constellation. From Earth, it seems to have the shape of an eagle. Interestingly, astronomers didn't expect to find a high-mass black hole lurking so relatively close to Earth and remaining undetected for so long. Okay, we can probably admit that this stellar black hole is just a small fry compared to supermassive black holes like the one that dominates the center of the Milky Way. I'm talking about Sagittarius A star. This space giant has a mass of 4.2 million times that of the Sun. While a stellar black hole forms when a star collapses, supermassive black giants have their own ways of seeing the light of day. They are usually the result of mergers of progressively larger and larger black holes. We'll talk about that later. First, let's speak a bit more about how stellar black holes form. When stars near the end of their lives, they typically inflate, lose a lot of mass, and cool to form what we know as white dwarfs. Such massive stellar black holes as Gaia BH3 are believed to form when a star doesn't contain heavy elements and loses not so much mass over its lifetime. Such stars are called metal poor. Afterward, instead of cooling into a white dwarf, this star collapses into a black hole. The companion of Gaia BH3 is a very metal-poor star. It suggests that the star that collapsed and formed BH3 was metal-poor too. Astronomers know of about 50 stellar black holes in the Milky Way. Some black holes are larger than others. You see, the universe is filled with black holes. Some of them are sprinkled randomly throughout galaxies. Others, those giants we know as supermassive black holes, sit at the center of galaxies. While stellar black holes are usually just a few times bigger than the Sun, such space monsters can weigh from 1 million to 1 billion solar masses. But even though they're so much heavier than our star, they're packed into a relatively small area. On a cosmic scale, of course, the size of our solar system or so. Some astronomers think supermassive black holes could form by several stars colliding and collapsing at once, while other experts state that such space objects might have started growing several billion years ago. At first, a small seed appears somewhere out there in space, which then gradually increases in mass to form a black hole. This seed does it through the process of accretion, which basically means gathering more and more matter around itself. Besides the absence of any precise information about the formation of black holes, there's also the black hole information paradox. If a black hole has some mass, and as we know, these spaced objects have a lot of it, then, according to the first law of thermodynamics, it should have a temperature. And according to the second law of thermodynamics, it should also radiate heat. Stephen Hawking showed that black holes are supposed to emit radiation too. These days, this kind of radiation is called Hawking radiation. It should form at the boundary of a black hole, but after proving it, Hawking pointed out a paradox. If a black hole is capable of evaporating, some of the information it contains can be lost forever. The problem is that the information contained in thermal radiation emitted by a black hole gets degraded. It doesn't repeat any information about the matter swallowed by a black hole before. Such an irreversible loss of information contradicts one of the basic principles of quantum mechanics. Physical systems that change over time cannot create or destroy information. It means we must be missing something. Both physicists and mathematicians have tried to come up with different ideas, but they ended with pretty weird results. Some have even claimed that the universe could be holographic. It means that the universe that we know and love is actually the result of some mysterious interactions at the infinitely distant boundary. I told you, black holes are really strange. At the same time, we have definitely found space objects that seem to have the properties of black holes. For example, look at this image of black hole M87 star. It certainly looks like a physical object, but what if black holes don't exist at all? There's an idea that black holes are actually gravastars, a blend of gravity, vacuum, and stars. This theory was first proposed in 2001 by Emil Mottola and Pavel O. Mazur. They hypothesized that at one point during the collapse of a large star, intense gravity might transform its matter into a new state. It's similar to what occurs when atoms are cooled to such low energy states that they start acting like a single superatom. When we speak of gravastars, a star might collapse to the point of the event horizon, or the point of no return, and then its matter is transformed into a new state. It exerts enough outward pressure to prevent the star from collapsing into a physics-defying singularity. In gravastars, an ultra-thin, ultra-cold, and ultra-dark indestructible shell surrounds heavily wrapped space-time. This new form of matter turns out to be very durable, but it's also a bit flexible, like a bubble. So anything that's trapped by the intense gravity of a gravastar and smashed into it gets obliterated and then assimilated into the shell of this bizarre space structure. One of the benefits of the Gravistar theory is getting away with those messy paradoxes connected with information and singularities. But even though this idea sounds kinda cool, it doesn't explain the phenomena we observe. And we've definitely observed something that looks like black holes. On the other hand, look at this shadow. It isn't caused by the trapping of light in the event horizon. It's a slightly different phenomenon known as the gravitational redshift. It makes light lose energy when it moves through a region with a powerful gravitational field. So, potentially, it could be a gravistar. When the light emitted from the regions close to the alternative objects reaches our telescopes, most of its energy is already lost to the gravitational field, which causes the appearance of this shadow. And still, like with black holes, things get complicated when you add rotation to the equation. Many experts are sure that gravastars would not be able to remain stable during rotation. But wait, it gets even more bizarre. There are suggestions that the insides of gravastars could contain a series of thicker shells. Those are known as nestars, something like a Matryoshka doll. Of course, these theories aren't perfect yet. Astronomers still have a lot of work trying to build functioning models. There's also a chance that both black holes and gravastars exist. But then, we've got another problem on our hands. How can we distinguish between the two? Some theories suggest that these different kinds of space objects should also emit very different gravitational radiation. It could allow us to figure out whether we're looking at a gravistar or a traditional black hole. Black holes are massive, the densest objects in the universe. They have such a great mass that their gravitational pull doesn't let anything, even light, escape their clutches. But in this terrifying world of black holes, there are monsters that are in a league of their own. Recently, astronomers discovered a black hole that is 33 billion times as heavy as our Sun. This space giant sits at the center of a supergiant elliptical galaxy called Abell 1201, which is located 2.7 billion light-years away from our planet. This black hole is so large it was given a rare designation, an ultra-massive black hole. No wonder. It's more than 8,000 times heavier than the supermassive black hole at the center of our home Milky Way galaxy. This ultramassive black hole was the first one to be discovered with the help of gravitational lensing. This method is based on the fact that very massive objects such as galaxies bend the light from a more distant object, magnifying it. A great thing about this method of research is that it allows astronomers to study inactive black holes too. It could help us detect loads of new black holes beyond our universe. That's what the area surrounding our galaxy is called. Probably it would help us find some exotic objects we've never seen before. Now, let's speak about another awesome instrument that efficiently helps us explore space, the James Webb Space Telescope. When it stares at young galaxies, which would look like mere red specks to you, it sees an astonishing number of cyclones churning at their centers. Those are black holes. Interestingly, giant black holes were believed to be big players in early cosmic history. But James Webb regularly finds an unexpected number of these beasts. For example, using the telescope, astronomers have detected a supermassive black hole from when our universe was less than 600 million years old. In universe terms, it's just a baby. This is the most distant actively feeding supermassive black hole ever observed. It's located at the heart of its host galaxy called Ceres 1019. The black hole is surprisingly small and not massive at all. It's actually one of the smallest found in the early universe. It's equal to approximately 9 million suns. It might sound like a lot, but in reality, supermassive black holes tend to grow to billions of times the mass of our star. There's another unusual thing about this find, and scientists are having a hard time trying to explain it. You see, it's supposed to take way longer than 600 million years for a supermassive black hole to grow to its full potential. The development happens when a black hole either feasts on surrounding matter or merges with a larger black hole. Even black holes similar to the one at the center of our Milky Way galaxy, which is almost 4.3 million times the mass of our Sun, are supposed to be seen in the more recent universe. Actually, scientists have long suspected that supermassive black holes probably existed in the early universe. But this theory has been proven only thanks to the JWST and its infrared eye. It's shown that the black hole Sears 1019 is actively munching on all the matter it can lay its hands on. Such feeding black holes are usually surrounded by swirls of gas and dust, falling inside them, called accretion disks. The gravitational force of a black hole heats this matter, and it makes the disk shine. And that's not all. Extra strong magnetic fields produced in this process channel the matter to the poles of the black hole. From time to time, this matter is released into space in twin, powerful jets. They move at a speed that is close to the speed of light, which generates incredibly bright light. Astronomers were watching the galaxy hosting the unusual old black hole as part of the Cosmic Evolution Early Release Since survey. They saw the galaxy as it was when our 13.8 billion-year-old universe was just 570 million years old. Besides the super old black hole, scientists spotted two other ones. Those probably appeared 1 and 1.1 billion years after the Big Bang. They also discovered 11 ancient galaxies that existed between 470 and 675 million years after the beginning of cosmic history. Now, how about having a look at the biggest black holes astronomers have found so far and finding out what would happen to Earth if one of them was to enter the solar system? NGC 6166 is a monster that has grown to have a mass of 30 billion solar masses. It's an elliptical galaxy that has an active nucleus at the center. It's also one of the most luminous sources of X-rays. The galaxy's supermassive black hole powers two symmetric radio jets in the opposite direction, which is the result of the infall of gas into its center. Another peculiar thing about NGC 6166 is that it shows a blue shift, which means it's moving towards us. Is it time to pack up and move out of our solar system? The next supermassive black hole is located in the constellation of Draco, approximately 10.4 gigalight-years from us. The mass of this supergiant is more than 30 billion solar masses. Besides being incredibly massive, the black hole is also really big. If it replaced our Sun, the diameter of this hole would extend to the orbit of Pluto. The next black hole is one of the most interesting on our list. It has a mass of 40 billion solar masses and is actually a blazar. It's the most energetic of all quasars, super bright distant objects. The blazar's luminosity is 300 trillion times that of the Sun, and more than 25,000 times as great as the luminosity of all 100 to 400 billion stars of the Milky Way galaxy combined. But since the distance to this quasar is about 12.1 billion light-years, we can't see it directly. But we know that the central black hole of the quasar consumes huge amounts of matter, about 4,000 solar masses of material every year. IC 1101 is a supergiant elliptical galaxy. It's the most massive known galaxy so far. Since this galaxy is elliptical, it isn't filled with gas. That's why the star formation in that region is very low. As for the black hole at the center of this galaxy, it lies in the mass range of 40 to 100 billion solar masses and emits clear radio signals. But wait for this champion. Astronomers have discovered a gravitational space wonder that has grown to really unimaginable proportions. The black hole I'm talking about is TON 618, and it's a mind-boggling 66 billion solar masses. Yep, we've got another ultra-massive black hole here. Imagine gathering all the stars in our home Milky Way galaxy and squishing the matter they're made of into one black hole. And it still won't be enough to create a ton 618. If this monster of a black hole replaced the Sun, its radius would be more than 40 times the size of Neptune's orbit. You know that black holes are incredibly dense, but it doesn't mean they're some kind of space predators roaming galaxies and munching on everything they come across. Ton 618, for example, still has a whole galaxy filled with stars and other stuff happily orbiting it without getting pulled inside. So the perception of black holes as giant vacuum cleaners is wrong. In reality, it's incredibly hard to grow a black hole. Try and you'll see. And now, what if a supermassive black hole, like the one that dwells at the center of our home Milky Way galaxy, moved a bit closer to our solar system? The answer is simple. We'd be doomed. The distance between this huge thing and Earth would be several dozens of light years, and still, it would wreak total havoc on our planet. Earth, along with other objects making up the solar system, would be tugged into the black hole's orbit and doomed to spin around it for eternity. But you can relax and breathe out. Such massive black holes stay away from us at the moment.
The James Webb Space Telescope is an absolutely stunning piece of equipment, which is around 100 times more powerful than the Hubble Space Telescope. And the latter has managed to observe places that are around 13 billion light years away. But recently, James Webb has outdone itself. It spotted something it wasn't supposed to see. Astronomers using the telescope have detected a supermassive black hole from when our universe was less than 600 million years old. Just a baby. This discovery is the most distant, actively feeding supermassive black ever observed. It's located at the heart of its host galaxy, designated Sears 1019. The black hole is also one of the smallest and least massive ones found in the early universe. It's equal to approximately 9 million suns. It might seem like a lot, but in reality, supermassive black holes often grow to billions of times the mass of our star. But what is so unusual about this find, and why are scientists having a hard time trying to explain it? You see, it's supposed to take way longer than 600 million years for a supermassive black hole to grow to its full potential. It happens when a black hole either feasts on surrounding matter or merges with a larger black hole. Even black holes similar to the one at the center of our Milky Way galaxy, which is almost 4.5 million times the mass of our Sun, are supposed to be seen in the more recent universe. Well, to tell you the truth, scientists have long suspected that supermassive black holes could have existed in the early universe. But this theory has been proven only thanks to the JWST and its infrared eye. It has shown that the black hole Sears 1019 is actively munching on all the matter it can lay its hands on. Such feeding black holes are usually surrounded by swirls of gas and dust falling inside them. Such swirls are also called accretion disks. The gravitational force of a black hole heats this matter, which makes the disk shine bright like a diamond. Sorry, but that's not all. Strong magnetic fields produced in the process channel the matter to the poles of the black hole. And from time to time, this matter is blasted out of there in twin powerful jets. They move at a speed that is close to the speed of light, which generates incredibly bright light. By the way, astronomers were watching the galaxy hosting the unusually old black hole as part of the Cosmic Evolution Early Release Synth survey. They saw the galaxy as it was when the universe, which is around 13.8 billion years old now, was a mere 570 million years old. Besides the main character of this video, scientists spotted 2 other black holes. Those probably appeared 1 in 1.1 billion years after the Big Bang, and 11 ancient galaxies that existed between 470 and 675 million years after the beginning of cosmic history. The coolest thing about all these discoveries is that until recently, all research about things that existed in the early universe was mostly theoretical. But now, with the help of the James Webb Telescope, astronomers can not only see galaxies and black holes at unimaginable distances, but they can also measure them. This isn't the only discovery connected with black holes made recently. For example, not so long ago, scientists saw 2 stars slow down in their orbits around black holes, and concluded it was most likely the result of drag produced by dark matter. It was the first time astronomers might have discovered some indirect evidence that huge amounts of dark matter could surround black holes. Now, about that dark matter. What is it, and what does it consist of? Our universe consists of normal matter, and dark energy. Normal matter, which is everything you can see with your own eyes or with the help of instruments, makes up around 5% of the universe. Since it's such a small fraction of the universe, maybe we shouldn't call it normal? Dark energy takes up around 68%, and about 27% of the universe is dark matter. This dark matter is just one more space thing that confuses scientists to no end. If dark energy is a force responsible for the expansion of the universe, dark matter is supposed to explain how objects work together. Potential candidates for dark matter vary from strange particles to super-dim objects. But even though astronomers can't grasp what exactly dark matter is, they know for sure what it isn't. This matter is dark, so we can rule out visible stars and planets. It also can't be dark clouds of normal matter. Otherwise, scientists would be able to detect it. Dark matter is not antimatter, since astronomers don't see unique gamma rays that appear when antimatter comes in contact with matter. And neither is dark matter gigantic galaxy-sized black holes. In other words, dark matter is still as much of a mystery to us as dark energy. Anyway, back to the potential dark matter discovered around the black holes. If it is confirmed, it'll be a great breakthrough in dark matter research. What helped scientists come up with this idea is that dark matter interacts gravitationally, influencing ordinary matter. So, a team of researchers watched the orbits of two stars decay by about 1 millisecond per year, while they were circling their companion black holes. The scientists concluded that these changes in speed were the result of dark matter generating friction and a drag on the stars. With the help of computer simulations of the black hole systems, the team tested a model widely known in cosmology. It's called the Dark Matter Dynamic Friction Model, and it predicts a certain loss of momentum by objects that are gravitationally interacting with dark matter. And guess what? The simulation matched these predictions. The results of this research helped to confirm a theory that had existed for a long time, that black holes can actually swallow dark matter that comes too close. As a result, dark matter gets redistributed around black holes, creating areas with different densities, which can influence the orbits of surrounding objects, like the stars we've been talking about. Speaking of black holes, there's a theory that primordial black holes could actually be dark matter. This type of black hole is hypothetical since scientists have never got any real proof of their existence. Such holes are insanely old and quite tiny. By black hole standards, that is. Astronomers believe they could appear several milliseconds after the Big Bang. At that time, stars and galaxies weren't born yet. It means primordial black holes probably witnessed the entire history of the universe. By now, the smallest primordial black holes have most likely evaporated away, but some bigger ones can still be scattered out there in space. If primordial black holes indeed existed, they could appear because in some regions of space, it was hotter, other regions were cooler, and some areas were extremely dense. Scientists believe these dense spots could collapse into primordial black holes. The most curious thing, though, these holes might be so small exactly because they popped up right after the Big Bang. The thing is, the longer it took a black hole to appear, the larger it was. The mass difference between older, smaller, and younger, bigger black holes was incredible. Compare the mass 1,000 times greater than our sun's and that of a pea. There you go. Anyway, the idea of the connection between primordial black holes and dark matter, or rather, the idea of them being the same thing, remained unpopular for decades. But recently, scientists have realized there are many more black holes in the universe than they used to think, and it means that the theory might actually work. And the vast and still hidden from us population of Big Bang black holes could not only make up but be dark matter. After all, astronomers haven't discovered a single dark matter particle yet, even after decades of searching.
You might think falling into a black hole is as easy as falling into a giant pit, but boy, is it a whole different ballgame. To actually fall into a black hole, you would need some incredible luck and a dash of wizardry. Moreover, if you were watching something fall into a black hole, you wouldn't even see it. Why? Well, let's try to understand the magic of physics. Falling into a black hole is really tricky. First of all, to even have a chance of doing this, you would need to aim perfectly and start your journey from very far away. It's like trying to hit a tiny target from a long distance. That's because black holes exist within galaxies, which are filled with other objects like stars, planets, and gas clouds. These objects have their own gravitational forces that can influence the path you need to take. It's like you have to carefully navigate through the room, avoiding bumping into others or getting pulled off course by their movements. In a similar way, when falling into a black hole, you need to navigate through the influences of other celestial objects. As you get closer, things get even more complicated. Making even the tiniest change in direction would require a tremendous amount of energy that you wouldn't be able to generate. It's like trying to steer a spaceship with no fuel left. This is because the black hole's gravitational pull is immensely strong. Once you pass the point called the event horizon, there's no coming back. You wouldn't be able to control anything. Now, even if you somehow manage to get on the right path and avoid all the obstacles, there's still a dangerous situation waiting for you. The intense heat and energy around the black hole, called plasma, would fry you as you get closer. So, you would need some impossibly strong protection to get even close to it. But not only is it nearly impossible to fall into a black hole, it's also impossible to see someone falling in it. Why? Let's find out. Imagine you're standing far away from a black hole, watching something getting closer and closer to the event horizon. As this thing, let's say it's a spaceship, falls into the black hole, two very strange things start happening. First, the color of the spaceship will change. You see, the gravity near a black hole is incredibly strong, much stronger than anything we experience here on Earth. This intense gravity affects everything around it, including light. Now, light has this fascinating property where it carries energy. But when light gets close to a black hole, the powerful gravitational pull starts sapping away its energy, kinda like stealing it, making light weaker. And you know how when you look at a beautiful sunset, the sun appears to be this warm, reddish-orange color? Well, that's because when sunlight travels through our atmosphere, it scatters and loses some of its higher energy bluish colors, leaving behind the redder ones. So when light loses energy, it tends to shift towards the red end of the color spectrum. The same thing happens near a black hole. The light from the spaceship loses energy due to the black hole's strong gravity. So, the spaceship, which initially had its own color, starts looking redder and redder as it gets closer to the black hole. It's as if the black hole is casting its magical spell, changing the color of the spaceship itself. The second weird thing is related to time. According to a theory of general relativity, gravity can mess around with time itself. And it works in a very strange way, because none of you, not people on board a spaceship, will feel this change. For you, an observer in this scenario, time is flowing just like it always does. You're just sitting there, sipping your space lemonade and watching the spaceship's journey. For people on a spaceship, things are the same. Their watch ticks away at a regular pace, and they go about their day as usual. But, objectively, for you, it would be like watching a spaceship fall in slow motion. It will seem to you that it's been falling into a black hole for weeks or even years. You might turn 80 and the spaceship is still out there. Crazy, right? Now, if time slows down for the spaceship, it means the light it emits also slows down. So, imagine someone on that spaceship flicking a flashlight on and off. But because time is moving so slowly, the light coming from the flashlight also moves in slow motion. It takes ages for each burst of light to reach your eyes. You'll be watching a spaceship as if you're watching a video in super slow motion. And when light takes longer to reach your eyes, it becomes weaker and dimmer, just like a fading star. So, as the spaceship gets closer and closer to the black hole's event horizon, not only does it start looking redder, but it also appears dimmer. So, it becomes harder and harder to see the spaceship as it gets closer to the black hole. It slowly fades away, like a disappearing act on the grandest stage of the universe. Pretty mind-boggling, isn't it? But that's all about you, the observer. And how are people on board doing? What do you actually experience when you fall into a black hole? As you get closer to the black hole, something really weird starts happening. The gravity near the black hole is so powerful that it stretches and warps everything around it. So the difference in gravitational pull between your head and feet becomes significant. This difference creates a tidal force, which stretches your body like a long, thin shape. It's a process that's scientifically called spaghettification. Essentially, you would be stretched into a human noodle. Being turned into spaghetti might sound fun for a pasta lover, but it's definitely not so great for an astronaut. Meanwhile, colors around you begin to warp and distort, creating a dazzling light show. It's like riding a roller coaster through a rainbow tunnel. Twists and turns, flashes and sparks. It's an exhilarating, mind-bending experience. And then, what happens to you depends on the type of black hole. First, we have classical black holes. These are black holes that exist forever. If you fall into this black hole, it would take an incredibly long time to reach the center. The center would keep getting closer and closer, but you would need an almost infinite amount of time to reach it. So it would feel like your journey would never end. And then we have evaporating black holes. These black holes can evaporate over time due to a process called Hawking radiation. It's just like the ice cubes melting away. These black holes have a limited lifespan, and it's basically impossible to fall into one of them. As you approach the evaporating black hole, you find yourself hovering near its edge, the event horizon. It's like being stuck at the entrance of a super cool amusement park. But guess what? This amusement park is shrinking. The black hole is evaporating, and as it does, the event horizon gets smaller and smaller. So you stay right at the edge, tracking its every move, but you will forever stay in this event horizon without ever crossing it. But remember, once you pass the point of no return, there's no way back. You're on a one-way ticket to the mysterious heart of the black hole, the singularity. At the singularity, everything goes bonkers. Our current understanding of physics goes haywire, so it's a bit like entering a magic show. What happens once you reach the singularity? Is there anything on the other side of a black hole? We have no idea. It's a big mystery for us, but maybe we'll figure this out someday. So, my friend, it's best to admire black holes from a safe distance and let your imagination soar with the incredible wonders they hold. Just remember to keep your pasta on your plate and not near these cosmic spaghetti makers. Imagine a powerful giant, like the sun, clashing with a tiny yet mighty opponent, a small black hole. The collision is imminent, and the fate of the solar system hangs in the balance. Will the sun be able to withstand the intense gravitational pull of a tiny black hole, or will it be swallowed whole? The answer lies in the forces at play in this mind-blowing cosmic collision, so let's break them down. First of all, what is a black hole? A black hole is a region of space where the gravity is so strong that nothing, not even light, can escape from it. Like a cosmic vacuum cleaner, it sucks up anything that gets too close. It's so massive that it warps the fabric of space-time around it. Black holes are one of the most scary and mysterious objects in the universe, a powerful force of nature that defies our understanding of physics, a true enigma of the universe. Black holes come in different sizes, from small ones that are only a few miles wide, to supermassive ones that are billions of times the mass of the sun. Most of them are formed by the collapse of massive stars. After the black hole is born, it starts to grow in size by eating everything in its path. And if two or more black holes collide with each other, they can merge into one enormous cosmic monster in a terrifying dance. But what about the smaller ones? The smallest known black holes are called stellar black holes. It's a type of black hole that weighs 3 to 10 masses of our sun, while being very small. It's like taking all the matter in the solar system and squeezing it into something the size of New York City. And yes, it's considered very small. Just for comparison, Intermediate mass black holes weigh between 100 to 1,000 solar masses, and supermassive black holes weigh millions or billions of solar masses while being unimaginably huge in size. So, stellar black holes are basically nothing compared to their relatives. Imagine a massive star, bigger than our own sun and with a heart made of nuclear fuel, burning bright and hot. But as the star runs out of fuel, gravity takes over and starts to squeeze the star. The more it squeezes, the hotter it gets, until the star's core reaches a temperature of billions of degrees. Eventually, the core collapses under its own gravity. This creates a massive blast called a supernova. This collapse creates a singularity, which means a point of infinite density and gravity. This point is surrounded by an event horizon, the invisible line beyond which nothing, including light, can escape. And just like that, voila, a stellar black hole is born. Pretty mind-blowing, isn't it? Stellar black holes are the most common type of black holes we know of. These guys can be found all across our galaxy. So, what are the chances that such a little monster will come for our sun? And in that case, what will happen to us? Well, actually, the likelihood of the sun colliding with any black hole is incredibly small. It's almost impossible for it to happen. Even though stellar black holes are the most common type of black holes in our universe, they aren't common at all. The chances of the sun and some black hole crossing paths is so rare, it's basically like winning the intergalactic lottery. Only this win wouldn't be that pleasant. For 2023, the closest known black hole in our solar system is Gaia BH1. It's about 10 times heavier than our sun, and even this one is about 1,600 light years away from us, which is a quadrillion miles. So, it's safe to say that our sun is not going anywhere anytime soon. But never say never, right? Just like with any astronomical event, we need to understand the different ways something like this could happen. For example, it would be possible if a rogue black hole passed through our solar system, much like a comet or asteroid passing by. Unfortunately, unlike comets and asteroids, black holes are invisible and can only be detected by their gravitational pull. So it's not like we'd see a big, ominous black hole hurtling towards us. Rather, we'd only know it was there if it caused some sort of disturbance in the orbits of nearby objects. So what now? We know that the sun is a massive, luminous star at the center of our solar system. It's about 4.5 billion years old and has enough fuel to last for another 5 billion years. This star is so big that it's hard to even comprehend its size. In fact, if you were to put all the planets in our solar system inside of it, there would still be room for more. And it's so massive that it contains almost 100% of the total mass of the solar system. So it's hard to imagine how some insignificant small black hole thousands of times smaller than this star can devour it. And you're right, it won't. Well, at least not completely. So imagine if a rogue black hole arrived in our solar system and has begun to approach the sun. As it gets closer and closer, the black hole's immense gravity will start to pull the material from the surface of the sun. The sun would start to get stretched and distorted. This is called spaghettification. Imagine a rubber band being stretched until it snaps. That's kind of what would happen to it. This gathered material will form a swirling disk around the black hole, called an accretion disk. As more and more material is pulled in, the disk will heat up and start emitting intense radiation. And as the sun gets pulled in, it would start to release massive amounts of energy in the form of light and heat. The sun would become much brighter and hotter than before. The sun's outer layers would be vaporized, creating a massive cloud of gas and dust that would expand outwards. It would be like a cosmic fireworks show, but with terrible consequences. Even though it would be one of the most spectacular views in the universe, we wouldn't be able to see it. As you might have guessed, the Earth would be in for a really rough time. The intense radiation and solar material would cause massive wildfires, and the intense heat would vaporize the oceans. The Earth would be bathed in a constant stream of high-energy particles, and the atmosphere would be ionized. In short, the chances of any life surviving would be close to zero. And this collision would have far-reaching consequences not only for the Earth, but for the entire solar system. The intense radiation and heat would vaporize everything in its path. all the planets would be destroyed. Now, the Sun being a larger object than a typical star wouldn't be completely devoured by the black hole, but it would be significantly distorted and disrupted. The intense gravity of the black hole would cause the Sun's outer layers to be pulled away, creating a massive blast called a tidal disruption event. But either way, in the end, the black hole would win. It would grow in size, and a new accretion disk would form around it. As we've seen, the collision of the Sun with a black hole, whether it be a tiny or stellar one, would be an epic and catastrophic event. But thankfully, as we've already mentioned, the likelihood of such a collision happening is extremely low. However, that doesn't mean we should stop studying black holes and their potential impact on the universe. The more we learn about these mysterious objects, the better equipped we'll be to understand and predict their behavior. So, let's keep researching, exploring, and observing the depths of space. And who knows, maybe one day we'll come across a black hole that's just too curious and gets too close to the Sun. Let's hope by that time, we will already be living on other distant planets.
Now really, an object weighing billions of times the mass of our Sun must be easy to find, right? Wrong. Unfortunately, it might not be that simple, like in the case with a missing black hole. But let's travel to the galaxy cluster Abell 2261, hosting a supermassive black hole at its center. Or at least, that's where it's supposed to be. The main problem is this giant space phenomenon is nowhere to be found. Now, supermassive black holes are mega monsters, churning slowly at the center of their home galaxies. They gather tremendous clouds of gas and dust around them, which makes them swell up to sizes the human mind can't begin to imagine. If a supermassive black hole, like the one that dwells at the center of our home Milky Way galaxy, moved even a little bit closer to our solar system, we'd be doomed. The distance between this huge thing and Earth could be several dozens of light years, and still, it would wreak havoc on our planet. Earth, along with other things making up the solar system, would be tugged into the black hole's orbit and doomed to spin around it for eternity or longer. Hey, who knows, right? So, it's good that such black holes stay away from us at the moment. So, let's see what happened to that runaway supermassive black hole from that gigantic cluster of galaxies around 2.7 billion years away from our planet. Scientists have been looking for it with the help of NASA's Chandra X-ray Observatory and Hubble Space Telescope. But so far, no result. The main problem with finding a black hole is that it's, black. And space is, you guessed it, black too. So there's no contrast whatsoever that could help astronomers spot the hole. But scientists haven't given up yet. After all, they have a lot of other technologies to find black holes, small and big, in the vastness of space. Some of these methods involve watching the stars orbiting black holes. Sometimes it's a faint gravitational wave signal, which is produced when two black holes collide. But the most reliable technique is watching dust and gas falling to their doom. The thing is, black holes are space objects with insane gravity. So, regions of space surrounding them are usually a bit chaotic, gas and dust getting pulled into the bottomless abyss, compressing and heating up. In the process, it releases a flood of X-ray radiation. So, astronomers look for extremely bright X-ray sources in the universe. Chances are those are the last gasps of giant clumps of material before they disappear into a black hole. Then, why can't scientists find such X-ray signatures left by the black hole in Abell 2261? One of the most mysterious things about its disappearance is that radio telescopes have spotted some signs of massive plumes of superheated material launched at one point within the last 50 million years. These plumes were most likely caused by a large black hole, which is nowhere to be found these days. So, at the moment, we can only play a guessing game. Maybe two medium-sized black holes collided, pushing the newly merged giant out of the center of the galaxy. The observations of the stars in that galaxy have shown a clump of dense material a few thousand light-years away from the galaxy's core. Maybe it's the runaway black hole, but disappointingly, no X-ray signals are coming from that clump. Or the hole might still be there in its rightful place, but it's, slumbering. If it doesn't get a fresh supply of gas and dust, it has nothing to feed on. As a result, it can't release a flood of X-rays. But again, the answer, do not disturb, the black hole is sleeping now, isn't very satisfying. Why isn't it getting its space food? What happened 50 million years ago? What is that clump of material speeding away from the galaxy center? So many questions, and no answers so far. At least, we know what black holes look like. Well, kinda. It's actually the shadow of a black hole's event horizon, visible against the glowing superheated material falling inside the hole. The first ever mugshot of a black hole appeared in 2019, but the data for its creation was collected in 2017. It took an international team consisting of more than 200 astronomers 2 years to assemble the image. We can admire this amazing space phenomenon thanks to a vast global network of telescopes called the Event Horizon Telescope Collaboration, or simply EHT. Why such a name? The thing is that the event horizon is a point of no return on the outskirts of a black hole. When something, for example, matter, radiation, or light, reaches this boundary, there is no way for it to escape the black hole's clutches. Anyway, to capture that very first image of a black hole, scientists created a virtual telescope that turned out as big as our planet by combining the power of 8 powerful radio telescopes. But it wasn't an easy feat. The researchers had to simultaneously point the telescopes in a meticulously planned order with the help of precise atomic clocks set on each telescope. Plus, to keep the chances of rain and bad weather to a minimum, they even constructed the telescopes in super dry regions, such as the Atacama Desert in Chile and the South Pole. On each observation day, the telescope gathers roughly 350 terabytes of data. That's 10 times the amount of data collected every day at the Large Hadron Collider. But let's speak more about black holes themselves. There are stellar black holes, smaller but even more dangerous than their supermassive peers. They appear when stars that have run out of their star food fall into themselves. If a star used to be big enough, it keeps compressing and compressing some more, and voila! A baby stellar black hole is born. But even if I call such a hole a small one, it's still 5 to several tens of times heavier than the Sun. Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have the mass of 1,000 SUVs. One theory claims tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple mini black holes pass through our planet every day. There is a supermassive black hole smack dab in the middle of our galaxy, the Milky Way. Its name is Sagittarius A star, and it's 4.3 million times as heavy as the Sun. And nope, we aren't going to be pulled into this hole. It's more than 26,000 light-years from Earth, too far to have any influence on our planet. By the way, recently, astronomers have discovered that this supermassive black hole might be leaking. If it's true, it probably means that Sagittarius A star isn't a sleeping giant, as previously thought. It might still be active. And the leakage recorded by scientists may be the hole hiccuping while swallowing clouds of gas. Maybe we should burp this baby? If you ever find yourself near a black hole, get ready that time will significantly slow down. It may work for you if you aren't eager to grow older. Just don't let yourself be tugged beyond the point of no return. Another danger of hanging around a black hole is that it might start behaving like a massive galactic volcano. From time to time, black holes flare up, but instead of spewing lava, they produce enormous amounts of energy, and it makes gaping holes in the surrounding material and gas. A short time ago, scientists discovered one of the largest craters in the universe. Radio and X-ray telescopes detected a supermassive black hole that threw a temper tantrum many years ago. It happened in a galaxy cluster about 390 million light-years away from Earth. The crater left behind, which was actually a hole punched in the cluster's hot gas, could fit 15 Milky Way galaxies. Okay, mind blown, I'm out of here.
Black holes, an enigma that has puzzled scientists and captivated our imagination for decades. But what's hiding inside of a black hole? Is it a void? A bottomless pit? A parallel universe? We don't know for sure yet, but scientists might have some ideas. So let's hear them out. Picture this. In the vastness of space, there's a supermassive star shining bright like a diamond. But like all good things, this star's party can't last forever. Eventually, it runs out of fuel and goes out with a bang. Quite literally, the star collapses under its own gravity, creating an implosion. Now, this collapse is so intense that it creates a bottomless pit in space, like a sinkhole. This is what we call a black hole, the ultimate no-escape zone, sucking up everything in its vicinity, including light. Imagine yourself approaching a black hole. The black hole itself doesn't emit any light, but you can notice a dazzling display of cosmic fireworks surrounding it, the accretion disk. It's like a celestial carousel of gas and dust swirling in a mesmerizing dance around the black hole. The incredible gravitational forces pull all this material from their surroundings, creating this celestial furnace. Of course, it's very unlikely that you would have survived in this place. Temperatures here soar to millions of degrees. Also, it's constantly dazzling X-rays and high-energy radiation that can be detected from telescopes on Earth. But let's imagine that you did survive, somehow. As you get closer, you notice a mysterious boundary looming ahead, the event horizon. It's a point of no return, beyond which the laws of physics seem to go haywire. Now you're stuck in a space traffic jam, and no matter how hard you hit the gas, you're going nowhere. Once you cross this threshold, not even light can escape. And now, you inevitably fall into a black hole. What do you see around you? According to the genius physicist Albert Einstein, space and time aren't separate entities, but rather intertwined in a fabric called space-time. It's like a cosmic trampoline that can stretch and bend if you place something heavy on it. And black holes are super heavy, which is why they distort this trampoline in the most extreme way possible. So when you venture close to a black hole, you're in for a roller coaster ride. The curvature of space-time becomes so intense that it's like a whirlpool pulling everything in, even light itself. Everything around you looks like a space funhouse with distorted colors and rays of light that keep shifting. All this makes you feel like you're doing the moonwalk on a treadmill. Also, the curvature of space-time around a black hole is so extreme that it creates a phenomenon called time dilation. Time near a black hole moves at a different pace than in the rest of the universe. The closer you are to the black hole, the slower time ticks, like a slow motion effect. And the deeper you fall, the weirder things get. The laws of physics seem to break down before your very eyes. But suppose you somehow manage to survive all this madness. Where exactly are you falling? What awaits you on the other side? Is there even an other side? As you venture deeper into the celestial maelstrom, you reach an elusive and mysterious point called the singularity. It's the heart of a black hole, a place where all matter and energy are crushed into a single, unimaginably dense point. Imagine cramming masses of entire stars to something that is essentially a pinprick. And now that you're here, forget about the usual rules of physics. Welcome to a new realm, where the known breaks down and the unknown takes over. So, what does this unknown look like? Well, there are a couple of theories. First off, it could be a gateway to other dimensions. What if there are multiple universes hiding within black holes, like nesting dolls? According to this theory, The interior of a black hole could be a portal to a parallel universe with its own set of physical laws and possibilities. This parallel universe could be drastically different from our own world. What a mind-bending idea! Or what about wormholes? Imagine black holes forming a space subway system, connecting different regions of space and time with each other. These theories suggest that the extreme gravitational pull of a black hole could create a wormhole, a tunnel that could transport you to another galaxy, or even to the past or future. It's like finding a secret passage in a video game. That's not all. Some scientists propose that inside a black hole, we might find some exotic matter, some strange matter with weird properties or negative energy density. If that's the case, this would defy our understanding of the universe. And finally, one of the most mind-bending theories is that a black hole could actually lead to a white hole. Imagine, as you fall further, you suddenly find yourself in a blindingly bright space show. You're in a white hole. This is a fountain that's spewing out matter, energy, and information into the universe with reckless abandon. The birthplace of new universes. You see, while black holes are known for their event horizon, white holes have an anti-event horizon. With black holes, everything can enter and nothing can come out. With white holes, it's the other way around. They repel everything. White holes are hypothetical objects. Their existence hasn't yet been proven. But if it turns out that they exist, they could be connected to black holes. It makes sense. Black holes suck everything in, and white holes should take their matter from somewhere. And all this matter and energy coming out of the white hole could potentially form new universes. Together with black holes, they could form a universal cycle of creation. The end of one universe leads to the birth of another. All these theories are beautiful and fascinating, but here's the catch. There's still no concrete evidence of any of them. Black holes still remain one of the biggest mysteries of our world. Unfortunately, studying these mysterious beasts isn't easy. They're super elusive, and this is one of the biggest challenges for scientists. Black holes don't emit light, so they can't be seen directly. They're essentially invisible to telescopes that rely on light, making them incredibly difficult to observe. That's why scientists have to rely on things like X-ray emissions, the effects of a black hole's gravity on nearby objects, and other clues. They're also very unpredictable. For black holes, physics is like a fun playground. They warp space and time around them, which makes it difficult to predict and understand their behavior. But don't worry, space enthusiasts. The future of research in this field is as promising as ever. We've already made incredible discoveries. For example, in 2019, we captured the first ever direct image of a black hole. This is a central black hole of the galaxy Messier 87. A few years later, we also took a photo of a black hole in the center of our own galaxy, the Milky Way. This one is called Sagittarius A star. All this has opened up new avenues for research. And these aren't the only cool things we've discovered in recent years. Let's take gravitational waves, for example. You know how rocks leave ripples after falling into water? Well, gravitational waves are ripples in the fabric of space-time. They carry clues about the most cataclysmic events in the universe. They've allowed us to listen to the universe, unveiling previously hidden phenomena and events. And all these observations provide us with a new way to study black holes. We constantly make new advancements in technology. The James Webb Space Telescope will provide us with even more detailed observations and insights into the mysteries of black holes. There's still so much we don't know, but that's the beauty of science, the thrill of the unknown, and the curiosity that drives us to explore the mysteries of the universe. So, let's keep peering into the cosmic abyss on the thrilling quest to unlock the secrets of our world.